Okay, so this is the TFA Tech Forum session, and there's going to be a presentation by Olivier on the secure EL2 firmware. And without further ado, I'll hand over to you, Olivier.
Thank you, Joanna. So I'm glad today to present the ongoing work and roadmap related to the secure EL2 firmware. So this presentation is co-presented with looks like not. So we will see when we reach the contents that supposed to present. So just briefly going through an agenda. Two questions: why and what. So why an SLR and what is Hafnium in this picture, and we'll look at how Hafnium fits or is a candidate to being the EL2 firmware. We'll talk about the project goals, status, the planned TFA release contents, a few bits about the adoption of the PSA FFA specification, CI testing, what we do to upstream, and obviously some Q&A. We'll reserve time for this. So I guess we can start. So first, why are we talking about an EL2? Yeah, I recommend it's worth reading this white paper from one of our. So it's nicely describing the reason for adopting an isolation using hardware virtualization in the secure world. So you can click on the link. And from this document, I extracted this picture, which is the current state of things. So as we can see here, we have a number of components. Normal world on the left-hand side, secure world on the right-hand side. And what we can observe in the secure world is that EL3 contains two flavors of, and even three flavors of components. So the EL3 firmware is probably coming from the TFA object. Platform firmware coming from the silicon vendor, and a so-called secure payload dispatcher from the trusted OS, including a few specific bits from this trusted OS. And above at EL1, the trusted OS itself, including platform drivers, which might be provided by the silicon vendors. And
Olivier,
yep. Yes.
Sorry to interrupt. Your audio is a bit cracking. Maybe you want to turn off the video so people can hear you.
Yes, we can do that.
Quite clear. Thank you. Sorry for that. But yeah.
Oh yeah, maybe I need to attempt turning off the video. Do you hear me better now?
Let's see.
That way, yeah.
Is it better? So let's see. I will try to speak louder.
Your video is still on, by the way.
Yeah, I didn't find the right button to put it off. Sorry for that.
Let me see if I can do it. Stop video.
Yeah, now it's gone.
Okay. So yes, we are there. So yeah, this brings a few problems and challenges. which are about the trusted application ecosystem, because trusted applications at SEL0 really are tied to the trusted OS and are not necessarily easily portable. Another aspect is integration of code from multiple vendors, so trusted OS vendors, but also silicon provider at multiple layers within the overall secure world. About the principle of least privilege, so it happens that the secure world globally has kind of superpowers that EL3 and SEL1 both are both granted. So they share the same physical address space. So memory can be accessed either from SEL1 or EL3 with the same means. And lastly, the normal world is not protected from the secure world direction. So a bogus code or malicious code from the secure world at any layer can corrupt the normal world, which can be the hypervisor in the normal world or the one of the VM or the kernel. So yeah, that's the challenges. So one of the possible solutions is the ability to isolate by hardware multiple mistrusting trusted OSs. So for this, there is a hardware extension from the RMBA.4, so-called Secure EL2. There exists also a possibility to integrate an SMMU at overall platform level. And to achieve also, well, to address those challenges, a specification has been released, so-called PSA-FFA, formerly known as SPCI. So that's the firmware framework for A-class device. So this brings...
Actually, Olivier, sorry, just a minor point over there. The spec's been renamed again. It's just called FFA now, if that makes things easier. So I just wanted to point that out. I should have told you earlier. Sorry about that.
Sorry, you mean?
I'm saying that the PSA terminology has been removed from the name of the spec. It's just called the firmware framework for A-class now. Okay,
good to know. Thanks.
Yeah, all right.
So this specification brings a lot of things. And in particular, the notion of partition manager. So that's defined in the normal world and in the secure world. And for our matter here, that's the secure partition manager running at SEL2. And it attaches to define standard APIs for the various components. So between the hypervisor and VMs, between the SPM and secure partitions, and even between the hypervisor in the normal world and the SPM. So I will now let Andrew comment more on what is Hafnium, and will explain after how it maps the current work with the secure world.
A question on the previous slide?
Yes.
About the last point. Hi, it's Varun here. You talk about standard APIs. So do you envision all these secure partitions to move away eventually from the communicate, for example, they might be using?
So we'll talk a bit later about what we call the migration path, and under control of Hatchin, I guess, yes, the intent is to migrate to FFA as much as possible.
Yes.
Okay.
So just a quick point on that. So Communicate is a standard API as well, but its biggest limitation is that it only supports a single partition. FFA allows support for multiple partitions, so we do expect a migration. But yeah, like as Olivier said, we can circle back to that.
So Andrew, that's for you.
Hello, I'm Andrew from Google. I'm a software engineer who has been working on Hafnium as part of the Android security team. So we originally built Hafnium as a hypervisor both for the normal world and for the secure world and secure EL2 that Olivier was talking about. This was motivated by wanting to have a standard hypervisor for Android devices rather than different vendors building different hypervisors, and also to encourage things to be moved out of the secure world where possible, because there's a tendency for many things to be run in trust when they don't need to be run there, and to be able to isolate those from each other. So we've been working together with them on this FFA specification, and we would like Android devices to use that in the future. So we started building this as a minimal security-focused hypervisor for that purpose. But plans have somewhat changed since then, and we're now focusing more on KVM, particularly under this new protected KVM model that we're working on for the normal world hypervisor. So Hafnium will be built primarily as a secure world hypervisor, or SPM, as it's called in the FFA terminology. So the diagram shows here, this is Hafnium running in the normal world, which is something that's currently supported in the code, but not intended to be deployed to production. It's a minimal hypervisor, so it just does memory isolation and provides communication mechanisms between the VMs. It doesn't do any scheduling or interrupt handling or other things that would normally sometimes be done by a hypervisor. Instead, there is a special trusted primary VM or host VM, which in this case will be running Linux usually, which is responsible for things like scheduling. It just calls up to the hypervisor to switch between processes and send messages. And all the communication is done using the FFA spec with a few minor changes on top. So I think, do you want to go on to talking more about the secure world? Next slide.
Yeah, there was one bullet related to, I guess Hafnium already has some framework and infrastructure to communicate with a TEE, right?
Yes, there's a kind of some support in there for talking to a TEE running in secure EL1, which we've used for talking to Trusty, which is Google's home-written TEE. However, that's based on FFA. However, that will change somewhat once there's an SPM running in secure EL2. The current model is a limited model that only works for sharing memory with a single TEE. Yeah, so it's fairly small in terms of code size. It includes a reasonably extensive test suite and some rules on which subset of C is used, which make it somewhat more secure. And it currently has code checked in for running under QEMU under the ARM FVP and on Raspberry Pi hardware. There's a architecture dependence layer that has a few things like drivers for the IOMUs, UARTs, things like that, so that you can easily pull it to a new target. But the idea is that there's very few hardware drivers running in the hypervisor because most of those are delegated to a VM, which has access to the hardware. The hypervisor just keeps them separate. Did you have anything more you want to add to that, Olivier?
No, that's fair. If there is any question from participants, if not, I can move on. Okay, so as showed in the picture here, the Hafnium hypervisor runs at NSEL2, and so the intent is to use the same code base as what we call here the SPM-C component. So a bit of terminology from the FFA specification. Anything related to virtual machines in the normal world is called VM. Virtual machines in the secure world are called SPs, or secure partitions. SPM-C stands for the SPM core component, which is the core of the component isolating the secure partitions and running at SEL2. And we have another component called the SPMD, which is the SPM dispatcher, which inherits few properties from the former secure SPDs, secure payload dispatchers, and running at EL3. So this split between the SPMC and SPMD is not strictly mandated by the specification, but that's the way we intend to implement it as part of the TFA code base. And yeah, so one of the first target for TFA would be to have opt-t running as a secure partition on top of the SPMC, so as shown here, but not limiting the fact that we can have other secure partitions, so either another TEE or code running from code inherited from a silicon vendor. And really the intent is to, as much as possible, move code out of the highly privileged EL3 to the lower exception levels. And all of those components would communicate through the FFA protocol using the standard ABIs. So I said so Hafnium in the normal world is a good fit for isolating multiple secure partitions. So what the good job that Hafnium as an hypervisor did in the normal world is moved to the secure world to manage secure partitions. So the project transition from Google to trustedfirmware.org happened and was completed in June this year. The project has been relicensed for the core part, and I think the Linux driver didn't change the license. It's still GPL v2, but Hafnium itself, as the secure EL2 firmware, is BSD3. The project is co-maintained by ARM and Google, and the core feature development is handled within the open source group, and more specifically the TFA team within ARM. And so, as Andrew mentioned, the normal world hypervisor itself is not necessarily going to a product, although we still maintain it as it's still a good to schedule secure partitions. And this is also a sanity check for the FFA ABIs in the normal world. So
that's also a useful reference implementation for us as we're tasting the other parts of the interfaces.
Yes, okay. Yeah, just to state that really the TFA scope is really the SEL2 firmware, but as you mentioned, the normal world hypervisor is still maintained not because it has to go to a product, but for mostly testing reasons, and to sustain the FFA specification. So as said, we expect Hafnium to become an open source SEL2 reference firmware, part of a broader set of projects such as opt-t, which is already part of trustedfirmware.org, and the more generic TFA EL3 firmware. And one of the goals as well is to fully adopt FFA within Hafnium. So this is already well advanced in the normal side. I'm thinking, for example, about the memory sharing that Google has worked quite sensibly already. But when considering the secure world, there is still some amount of work to do, like how do we boot Hafnium in the secure world? What's the interaction with regards to power management? Few FFA ABIs missing. What happens for world switching between possibly a normal world hypervisor and the SPMC through the SPM dispatcher. Memory sharing, even if it works well in the normal world, it has to be somehow adapted to the secure world for VM to SP or SP to SP memory sharing. And interrupt handling also has to be reworked. I am not detailing too much here, but yeah, that's the non-exhaustive list of things that are necessary to achieve and part of those goals. So what has been done and what will be done next? So the development phased or cut into phases, starting end of last year, beginning of this year. So it has mainly been focused around how we boot things and prototype a first iteration for Hafnium in the secure world. Then phase 2 was related to secure boot, adding the mandatory FFA setup and discovery interfaces, and starting upstreaming patches as long as the project has been transitioned end of Q2. And currently, we are looking at adding the multi-core capability in the secure world and the Hafnium in the secure world. Through, there are different tracks. So multi-core boot, how interrupts are handled in the secure world, and the memory sharing, as mentioned earlier. And later, end of the year, a few other features like SMMU support, secure EL0 only partitions, or AH32 for secure partitions. That's features that should be added in the long run. And as shown also in this picture, so there has been already a release in the middle of Q2 for at least the SPMD component. So it's already part of the V2.3 release. I think it was around April this year. And we plan another release by Q4 with a first tag to the SPMC component. So a first tag in the Hafnium repository, embracing TFA as the EL3 firmware, the TFA test, but also Hafnium. So tagged as V2.4 release. And as shown as well, so it doesn't stop here. We aim to continue the development through Q4 and Q1 next year to add features and continue the hardening.
A question?
Yes.
So the last bullet point, the IO and SMMU support. So are you also planning to provide alternate paths for SoC vendors who might not have SMMU support on their suite? I mean, because all of this is new, so there might be some vendors who might not have full support. So will Hafnium provide an alternate path internally, or what are you planning?
So you mean by enabling or disabling the SMMU support?
Right. Yeah. So if someone does not enable it, then will there be any alternative path required in Hafnium, or is it up to the OEM to figure out how to support their solution?
So yeah, maybe two bullets as an answer. So and Andrew might comment more, but I think the SMMU or IOMMU support is already configurable as a module and within the Hafnium code base, and there are hooks onto which we can plug specific IP code. Andrew, correct me if I'm wrong here.
Yeah, that's correct, yes. So there is a set of hooks for integrating with a particular IOMU implementation, which you can implement for your specific silicon as necessary. The idea is that there'll be an included driver for the standard ARM SMMU, but other solutions can be added as a module.
Okay, thanks.
Andrew, is the expectation that the SMMU IP should kind of be as per the ARM SMMU architecture, or as long as it kind of fulfills some fundamental requirements that any IMMU or SMMU provides, it doesn't really matter?
I think the ARM SMU would be the kind of officially supported in the code-based option, but other IOMU implementations could be supported by their respective vendors by adding code for them.
Okay.
And you can choose at build time which one you use.
Well, one other thing is you don't need to have any IOMMU support, right? You just you don't need to enable the IOMMU at all. It's only useful for if you want secure IO, right? So
well, if you have DMA devices, you need to have an IOMU, or partitions aren't separate.
well, in the sense that you can the SOC will typically only allow non-secure transactions, so there is no writing to secure memory if you don't have an SMMU that does support two-stage translation, for example.
Like if you don't have DMA capable devices that can drive the S bit, then I guess you are safe, right? Everything is non-secure, then you get that level of isolation.
I mean, even for non-secure, if you share non-secure memory with a secure partition, then other non-secure VMs shouldn't be able to access that. So you need that to be enforced by the IOMU alongside the MMU.
But that would be taken care of by the IMMU in the non-secure side, right? Because that would make sure that the other VMs cannot see that memory using the non-secure bit. Sorry. That's just like partitioning the space between two VMs using a non-secure IOMMU, SMMU.
Well, that assumes that secure partitions can't access any devices which have DMA.
Yes,
so if that's
absolutely
true, then yes.
Yeah.
So
Yep.
I'm guessing that there will be at least one secure partition which will need some device access. For example, crypto for a crypto chip, right? So I think assuming that none of the secure partitions will ever access any device may not actually play out that way. So,
I guess that depends on the use case, but yeah, certainly in like on Android devices, I can't see it being the case that there will be. I think the IOMU will be required on Android devices in practice.
Yeah.
Other applications may be different.
So I mean, my intention to ask this question was just to understand if there are any inherent assumptions from Hafnium that there will be some drivers. So looks like even if we completely remove the IOMMU or SMMU driver or stub it out, Hafnium does not. I mean, Hafnium should still work. Of course, there will be other use cases that would be affected, but Hafnium
can certainly still run.
Yeah.
Can still run without an IOMMU driver, but it may not be able to make the security guarantees that it's trying to make.
Well, yeah, I don't agree with that statement. As long as you can't DMA into secure memory, if your IOMMU can DMA into secure memory, Hafnium should provide.
It's not just about secure memory though. It's about so part of the issue here is protecting non-secure memory from a malicious secure partition.
Right, but that's the job of the non-secure hypervisor, not the job of the secure hypervisor, right?
No, it's the job of the secure hypervisor, because the secure hypervisor controls the page tables for the secure partitions. And so if there's untrusted code in a secure partition, which there could be, like maybe some DRM code or something, then it's important to make sure that code can only access the memory it's been given access to, and not other memory, even non-secure memory.
All right. Yeah, I think that needs some discussion. I don't want to rat hole the meeting, but
in any case, so this is really initial investigation for now, and we plan the support by end of the year. But I suspect that there will be discussions triggered through the Hafnium mailing list to properly design this. And
Sure.
yeah, and yeah, second part of the answer to the initial question is, if I recall, the FFA spec provides definitions in form of manifests and how the SMMU, if there is one or multiple, by the way, are configured and what is the topology. So I think, and this will have to be refined in the discussions, that we might have the configurability to just disable the SMMU or IMMU if that's not necessary, if that's not required in a specific build. So moving on, that's the release content. So yeah, what we should remark here is so the v2.3 is done. It includes this SPM decode, which, by the way, is generic to support both an SPMC at SEL1 or SEL2, and I'll talk more about that just after. And for the v2.4 plan end of the year, so we expect to have a first tag for the SPMC component, and the intent is to have at least a minimal support to boot Opti as a secure partition, as showed in the picture at the beginning. So Opti being for us a full-fledged TEE, a reference TEE. It's not saying that it reflects the architecture for any trusted OS, but at least it's a bit more than a simple bare metal secure partition, or showing more of the real life use cases.
Olivier, quick question over here. So in the 2.4 timelines, when we have support to boot Opti, the changes that are required to Opti to be able to work with secure EL2, are these going to happen at the same time?
Well, that's where it requires coordination, I agree, because clearly our scope is TFA, well, EL3 and SEL2 within our team. And you're right, the end-to-end stack is large, starting from the normal world with the kernel, possibly an hypervisor in the normal world, EL3, SEL2, Opti at SEL1. That's many components, and we have the hand only on a few components, which are EL3 and SEL2. So that's right. It needs the coordination, and I know of ongoing work at Linaro to convert Opti to being a secure partition on top of an SPMC, and this has to be carefully followed.
Yeah. No, I saw that Jens is available as well, so that's why I thought I'd bring it up just so that we're aligned. Just being a bit opportunistic here.
Just to clarify, so trustedfema.org is supposed to provide the entire software stack, including all the changes needed into Opti and any TAs to demonstrate the full stack. Now, from an operational point of view, there are different teams doing different things. So Olivier represents the TFA, EL3, and SEL2, but both ARM and Linaro and other people are collaborating around Opti as well, with a goal of having the changes in Opti, yes, delivered as part of trustedfema.org as well, and Opti upstream in the same time frame.
Thank you.
Olivier?
I have a question.
Yes.
Sorry, I was going to say, have the changes for EL3 been scoped out? Do you know what kinds of changes will there be in EL3.1, for example?
So yeah, we expect more and more trusted OSs that trusted OSs adopt the generic SPMD component rather than having scattered SPDs, one for each trusted OS. And so BL3.1 consists in the generic part from TFA, but also at runtime the SPMD component. So that's mainly how BL3.1 changes here, I guess. Does it answer the question?
So, no, I think that's significant. So, you mean moving away from SPDs towards like one way of transferring to SEL2 and then SEL2 handling any payload, any VMs, secure partitions that it has, right?
Yeah, well, in fact, the more we move the code from EL3 to the lower exception level, the best it is. And we appreciate that it's not an easy thing, but we hope to enable some transition. And maybe that's a good transition to the next slide.
Sorry, Olivier, just wanted to add on that point that at least from the spec perspective, the SPMD component is indeed meant to be the single dispatcher, which kind of falls in the bigger picture of having only generic components as far as possible in EL3. And the intent is to, like, whether the trusted OS is running under secure EL2, in which case you have Hafnium, or whether the trusted OS is running under EL3, it should be able to use the SPMD component as a generic dispatcher instead of relying on its own dispatcher. Now, the migration to that is obviously not something which will happen in one go, because different dispatchers have their different requirements. We are working with the Opti dispatcher right now, but yeah, like this will be an incremental thing.
I see. Thanks for that. I was also thinking about changes in the boot order, but I don't think that that's going to be a big change. Like, we can guess that it'll be EL2, secure EL2 first before any of the trusted OSs run, and then non-secure EL2 runs, right?
Sorry, you broke up a bit. I didn't quite follow that.
I'm sorry, my internet connection might be weak. What I'm saying is that another change I can think of is the change in the boot order. So
right.
From EL3, it transitions to secure EL2 now, which then initializes secure OSs, and then it jumps to non-secure EL2. Is that right?
Yeah.
Yes, right. In fact, the change is done quite smoothly in the sense that TFA EL3 boots first, and then hands over to the SEL2 firmware, which itself initializes the secure partition sequentially. So if you have multiple trusted OSs, they will all get traversed once at boot time for initialization purpose prior to handing over to the normal role.
Question?
Thank you.
Question for the previous slide. So I think you talked about the partitions packaging. Just wanted to know if you, we are still planning to use the FIP package, so there won't be any changes on that on the coming up with a different format.
In fact, the changes done here integrate already to the TFA flow that you know, in the sense that we still use the firmware image package, but the secure partition payloads are assembled together into a single firmware image package image, including all the secure partitions.
Okay, so are you saying that they would reside outside the FIP, or would they still be part of the FIP?
No, sorry, it's part of it.
Oh, okay.
The secure partitions has their own manifest and binary, so they are made in a package, SP packages, and these packages itself are part of FIP.
Okay, thank you.
So on the migration path, as said, the SPMD component supports the pre-ARMVA.4 platforms, in the sense that the SPMC can be made run at SEL1 instead of SEL2. So there is an ongoing work in another team within ARM, adapting Opti as the SPMC at SEL1, so out of the context of SEL2. As said earlier, we intend to let the SPMD be generic as much as possible, in the sense we hope to have smoothly secure payload dispatchers, adopting more and more ARM standards, and use those ARM standards within the generic SPMD. So it's a difficult task, but the intent is to collect requirements from various trusted vendors to achieve that goal. And lastly, so there exists still this former SPM running at EL3 through the MM interface. So as said, we expect it to migrate to FFA RBI. And there is also a requirement for the SPMD to provide hooks for new SMC services that would go through EL3 and be forwarded to the SPMC, in the sense that the core of the service functionality would sit within a secure partition. So an SMC invocation from the normal world would be forwarded through the SPMC down to a specific secure partition for a specific service.
Just one more thing, Olivier, sorry. On the SPMC at Secure EL1, so there are patches which have been posted by ENs to add the support to Opti, and they are under review, I believe. So yeah, like if anyone has any feedback, please provide that.
So, quick question on the slide. So, for migration of existing platforms that use standalone MM with the existing SPM MM interface, what is the migration path we are seeing here? I mean, if the SPMC is something that is, and this question is specific for platforms that do not have a secure EL2. And what would be the migration path for those type of platforms, and platforms that do not probably will be using OptiOS?
That won't be using OptiOS, you're saying? They will be using OptiOS?
No, that will not be using OptiOS. What would be the migration path for those type of platforms?
Right. So the migration path, at least like from an architecture perspective, it's like twofold. One is that the interface that the secure partitions, or the standalone MM secure partitions use to talk to the partition manager, that would turn into FFA. That's like the first step. And then secondly, the normal world interface, the second step would be that the normal world interface, which uses MM Communicate, that starts using the FFA ABIs. Now, if we are talking about multiple secure EL0 partitions that are running under the control of EL3, I believe that's the architecture that you're talking about. So the spec supports that, and like Matteo and Olivier, you can comment on this, but I don't think we have plans of working on that front, like at least anytime soon, right? But happy to take contributions and such.
Yeah, that's correct. So the team itself have no plans to implement multiple secure partitions on a scenario without SEL2. This doesn't mean that we won't accept contributions if someone wants to contribute and maintain that kind of scenario. I believe what you're saying, Thomas, is also how do we migrate platforms which only have one single standalone MM, which has always been the case. And I guess Achin has given the let's say the architectural path. From a software point of view, we might look into who wants to pick that up, that activity, and post the related patches into, I believe, into EDK2 standalone MM package, because that will have to change, right? That will have to change and support FFA. Yeah, Achin, go ahead.
Yeah, so in fact, on that front, like we are working with Linaro separately, and like this is, again, taking a standalone MM partition the way it stands today and getting it to run with Opti. And one of the things that we are in the process of doing is getting this partition to talk FFA when it talks to Opti. And I believe the plan was to, the plan was definitely to post these patches to EDK2 as a very basic step towards removing the old interface that the standalone MM partitions used with TFA and replace that with FFA, and we can kind of definitely build upon that. Now, once this basic bit is upstreamed, then there's like the question whether this partition would just work with a TFA SPMD, right? Like that would require certain gaps to be filled as well, but that's where the contributions come in from partners.
Okay.
But yeah, there is some work happening in this regard.
Okay, so if I have understood this correctly, so on platforms that do not use an OptiOS, so there is a need for an SPMC implementation, a standalone SPMC implementation at Secure EL1, and that interfaces with the standalone MM at Secure EL0. Is that?
So okay, for platforms that don't use trusted OSs, they don't have Secure EL2. We're just talking about good old EL3 and Secure EL1 and Secure EL0. The model over there is that the SPMC and the SPMD components, they effectively fit in EL3. So it's like you can just call it the SPM in that case. Like the C and the D's cancel each other out. Think of it like that. And like the SPM component is responsible for managing these Secure EL0 partitions. So the architecture allows that, but yeah, like we're not looking at doing development on that right now.
Okay.
Yeah.
Okay. Thanks, Sachin. Yeah.
So as I'm seeing the clock is ticking, I will go a bit faster on the last slides. Around CI, two build systems and two CIs in a way, in the sense that we inherit what exists within Hafnium, which is a comprehensive list of 4 types of tests: host, unit test, architecture test, VM, API test, and Linux test. So on any patch submission done through trustedfirmware.org, there is a build script run, and successful completion of the scripts provide a verified +1 label. And this same script can be run locally on your own PC, so that it's easily reproducible. And on the other hand, we have a TFA daily CI implementation, testing the close integration between TFA components and Hafnium. We try as much as possible to not duplicate the coverage between both. And we expect also improvement to be done as part of an open CI project that is currently worked on within ARM, and reconcile both Hafnium and TFA CI's approaches. On the upstream, so this is now, as the transition is made, this is done through trustedfirmware.org Gerrit interface. We have few patches merged already, and a number of working progress patches under review, and you can have a look by clicking the link in the last bullet. And a few links for the resources. We have a slot granted for the Linaro Virtual Connect in September, so we'll give you another update by that time. And below are the links to the documentation, the specification, the FFA specification, documentation for Hafnium, and a design doc for the SPM, link to code reviews interface, the mailing list to which you can register, and the list of ongoing open bugs or feature enhancements through Fabricator. And that's the last slide. So there are a few backup slides you can have a look when at when the slides are made available. And if you have questions, additional questions, let us know. And thank you for your participation.
I have a question for Andrew from Google. And we've been talking about Opti a lot over here, but since Andrew is representing Google, I just wanted to also understand if, since they have their own trusted OS, are there any plans from Google's side to include it somewhere on the roadmap?
We plan for Trusty to support running under Hafnium with FFA, yes.
Okay.
That's what you mean.
Yeah. I wanted to understand from Trusty. But right now, is it, I mean, do you have a specific, as we presented the timelines, or is it just on the wish list?
There's some patches that are pending to add support for using a subset of TFA for memory sharing to Trusty. Beyond that, I'm not sure if there's a timeline yet.
Oh, okay.
That's certainly something we plan to do. I'm just not sure quite when. Depends on other priorities.
Right. Okay. But it's good to know that at least there's some motivation. Thanks.
Yeah.
I want to quickly ask, how do you plan to handle interrupts, the secure ones?
So it's ongoing work. Most probably this will be slightly different from how Hafnium handles interrupts in the normal world, in the sense that in the normal world the so-called primary VM has much ownership of the gig distributor, and it's probable that in the secure world we might not adopt such same primary VM concept, and that all secure partition in that perspective, it would be that we have more ownership of the gig within Hafnium itself at EL2, rather than handling interrupts within the primary VM and injecting interrupts to secondary VM like the primary VM does. It would be more on Hafnium in the secure world to inject itself interrupts to secure partitions. And so any physical interrupt would trap to secure EL2 while running in the secure world, and inject from Hafnium to a secure partition. Does it make sense?
Just like to add a bit more to that, from a spec perspective, we are looking at interfaces. We are looking at paravirtualized gig interfaces. So for the next version of the FFA spec, basically looking at including some guidance on how interrupt handling should be done. And I believe those interfaces that we are looking at, they will be available for public review in the near future as well. So that's one direction of travel that we're considering.
So Hafnium already has bits of a para-virtualized interface in a way that we would, in the first step, evolve slightly while running in the secure world. But as Achin mentioned, in the far end, we would adopt a more standardized para-virtualized interface. So it's in steps here. Yeah.
But it is Paravirtualization does look like the route that you're going to take.
Keeping in mind the complexity of gig emulation that we have run into in the normal world, that seems like a good choice, but happy to discuss it further, like if you have reservations.
Okay, thanks.
So we'll probably and for sure share more about the specific interrupt handling design through the SPM document shown for which the link is showed in the middle of this page. The community can comment more on this design and we can drive from there.
And I'm sure where necessary, we will have other sessions and making use of the TFA Tech Forum.
Yes, happy to do that.
Yeah, I think interest has implications for performance and security as well. So I think I would require a bit more detailed discussion maybe.
Yeah, I appreciate that the current design doc does not emphasize too much on how we plan to handle interrupts, but this will be iterations. So that's the first draft of the document, and for sure it will be enhanced as the development goes. Sorry, was there a question?
Yeah, hi, can you hear me?
Yes.
Yes, so I think previously you talked about EDK2 and adding some support there for other interfaces. So for interrupts as well, are you guys planning to change a little bit over there, because there's some standalone MMs they don't service interrupts at all, but now with the interrupt handling, are we proposing that we add some interrupt supports to the MM side?
Well, I would say now that's really the scope of enabling secure partition on top of SPM-C and Hafnium, and Matteo and Ashin can probably comment, but yeah.
Are we talking about secure EL0 partitions, or are we talking about MM partitions that run in secure EL1?
Secure EL0. I mean, mostly I was talking about standalone MM, where
right, so,
they don't.
Yeah, so standalone MM partitions, as far as I understand, at least we have an example for RAS interrupt handling on the SDI platform. So the partition itself is capable of being, there's a capability to delegate interrupts to the standalone MM partition, and that functionality will be preserved by the FFA architecture as well. So yeah, now when the code lands in the tree is a different matter altogether. But yeah, the architecture is there for that.
Okay, thanks.
So we've reached just over the hour now. So I appreciate some folks may need to start dropping off. I mean, if there's while the prime contributors are online, and if there's any sort of final urgent questions, otherwise we can take questions to the mailing list. And the presentation and the recording will be made available off the TFA Tech Forum meetings page in the next few days. Not hearing any final questions, so I'll stop the recording and finish the call if there's no last things anybody wants to say. All right, thank you, Olivier, Andrew, Achin, Matteo, for answering questions, and for everyone else on the call who have shown interest and asked questions.
Thank you.
Thank you. Thanks for having the session. Thank you.
Thank you.
Thank you. Bye, everyone.
Thanks. Thank you.
Bye.
Bye-bye.
Goodbye. Thank you.
Bye.
Bye.
Thank you.